I'm a number theorist, which means I spend none of my time thinking about numbers and all of my time thinking about geometry. Let me explain. You're familiar with the whole numbers, and the prime numbers, they're the ones that don't factor. But there's lots more than just whole numbers out there. And there's no reason to restrict ourselves. If we want, we can throw in something new and see what happens. Let's say we throw in the square root of 5. It's not a whole number, but it's the square root of 1, which is not so far off. Now when we do this, our primes change. Some of them stay prime, but some of them now factor into new primes. The question is, which ones? In this case, there's a nice simple pattern. In this grid, these columns, the primes stay the same, and these columns, the primes split. That's all there is to it. But there's more exotic things than the square root of 5, and we want to know what happens with them too. And it turns out you can't always just draw a grid. We're going to need some new ideas. Okay, so here's a new idea. You can tell whether a prime splits or not by looking for symmetry. Basically, the whole numbers can't tell the difference between the positive and negative square root of 5. All the whole numbers can see is that when you square them, you get 5. They look the same. So we can switch them around without anyone noticing. This is a symmetry. And when a prime splits, it has to obey this symmetry, meaning it breaks into two pieces that look the same. We can use this symmetry to understand which primes split. And this is where geometry comes in. We're much more used to thinking of symmetry in terms of shapes, rather than numbers, right? And even with all our fancy mathematics, that's basically still true. So we try to find geometric spaces with the same symmetries as our numbers. Then we can try to understand the symmetry in a geometric way, which is much easier, and which will help us understand our primes. There's a certain type of geometric things that are particularly good at this. They're called Shimura varieties. This donut is a basic example of one. Actually, it's just part of one. They have lots of different levels that you have to navigate. The nice one is called hyperspecial, and the rest are called bad. But the bad ones can tell us more if only we know how to understand them. I feel like there's a lesson in there somewhere. Anyway, my work is connected to understanding what happens at bad level. What you can do is break your Shimura variety down into smaller pieces, basically separating out the bad parts and the other parts. I'm working on the other parts, which are called Igusa varieties, and I'm trying to understand their symmetry. If we understand the symmetry here, it'll help us understand prime numbers better. So just to give you an idea, here's where we're at. Here's your Igusa varieties, here's your symmetry, and this is what it looks like. Which, okay, may not look like much, but this is only part of the story. This is the hard work it takes before we get to a simple answer. There's a nice simple answer out there, and we're well on our way. And when we get there, we'll let you know.